All right, peeps, let's start with number one. Okay, so we're going to factor the following if possible. If you checked out the notes, the only type of factoring that we talked about is GCF. Okay, and what GCF stands for greatest common factor. Okay, what the heck does that mean? It's pretty simple. Greatest common factor is, to put it in plain English, we were trying to find the biggest number and variable that can divide everything. In the problem. And when I say everything, I mean every term. Okay? So let's look at number one. If you look at number one, we have two terms. We have this term and this term. Again, a reminder, these are called terms. Okay? So what we're going to do here is, my goal is to factor or look at the numbers and figure out what's the biggest number that can divide both of these. So if you look, I like to take the smallest guy between the two. So we have number 12 and number 15. The smallest guy between the two is 12. So what I'm going to do is list everything that I know that can divide 12. Okay, we know 1 can divide 12. And I'm going to do it from smallest to biggest, okay? We know 2 can divide 12. We know 3 can divide 12. We know 4 can divide 12. We know 6 can divide 12. And we know 12 can divide 12. Okay? So these numbers at the top all can divide 12. I'm now going to do the same thing for 15. Okay? I'm going to list everything that can divide 15 from smallest to biggest. So 1, 3, 5, and 15. So when we're doing GCF, you got to be good with pretty much with multiplication and division here. Okay? So looking at these two lists that I have here, what I want to figure out is, what's the biggest number that they have in common. Okay? So if you think about it, do they have 12 in common? No. Do they have 6 in common? No. Do they have 4 in common? No. Do they have 3 in common? Yes. So 3 is my greatest common factor when it comes to numbers. Okay? So right now, my GCF is 3. Because 3 is the biggest number that can divide 12 and also divide 15. Okay? So notice that when I made my definition here, it's the biggest number and variable. So now I got to check, do I have a variable that divides? To check for variables, all you got to look for is, do the terms, in this case I have 2 of them, do they have the same letter attached? So we have an X here, nothing here. So that means since they don't share the same letter, there is no variable GCF, which means my GCF is only 3. Okay? So because of that, we can now continue. I need to now, once I found the GCF, I need to now factor. Okay? So I'm going to factor here, which means I'm going to take my GCF and I'm going to divide. Okay, so it's going to look like this. Take my GCF and divide. Okay, so now let's do that. What's 12 divided by 3? That gives me 4, and we bring down the X. Okay, we're done with him. What's negative 15 divided by 3? That's negative 5. And there's no X to bring down, so we're good. So after we divide, our answer goes in parentheses, and our GCF goes in front. Okay? This is called factored form. We have put it in factored form. What factored form is, to put it simply, is a multiplication problem. If you notice, what we turned our problem into a multiplication problem. Okay, so it was a polynomial, and now we turned the polynomial into 3 times this stuff. And anytime we turn it into multiplication, that's called factored form. That's factoring is basically turning into multiplication. Okay, so my answer is this. All right, let's jump over to number 3. Okay, we want to factor this, again, using GCF. So I'm going to make a list of numbers that divide 7. This one's easy. It's 1 and 7. A list of numbers that divide 10. It's 1, 2, 5, 10. And if you notice, they have nothing in common. So that means we do not have a number GCF. But now we got to check for the variables. Do they have a variable in common? Okay, this term has t squared, this term has t. They both have the same letter. So that means my GCF has to have a letter in it. In this case, it's t. But now we got to figure out the exponent of t. And what you want to do is always pick the lower power. So if this is a power of 2, and believe it or not, this is a power of 1. So the lower power between the two is t to the first power. So our GCF is t to the first power, but if you know math, you really don't have to put this little 1 here. Okay, so here's my GCF. Once we find my GCF, we divide the GCF away. Okay, and let's do the math. 7t squared divided by t. What we do simply here is, I have 2 t's on top. I'm taking one and dividing it out. So how many t's are left on top? 1. I'm left with 7 and 1 t on top. Okay. Now we go positive 10t divided by t. That's going to give me positive 10 because there's nothing to divide with the 10. I have 1 t on top and I'm taking 1 away. So that means there's no more t's. Now we turn it into a multiplication problem. So that goes in parentheses, and what do we multiply on the outside? Is our GCF. Okay, this is again in factored form. All right, let's jump down to 9. I did forget to mention here, I know they have a 1 in common, but we don't use 1 for GCF. Okay, we want to use other numbers besides 1. Okay, number 5. Make a list of numbers here. So the number that's actually in front here is 1. So I'm going to list all those numbers that divide 1, and the answer is 1. All the numbers that divide 9 are 1, 3, and 9. The only number they have in common is 1, and we don't use 1 for GCF, so we don't have a number for GCF. Let's jump into the variable. Do they have a common letter? And the answer is yes. So we're going to pick the lower powered one, which is this guy, x. That's our GCF. Once we find our GCF, we divide it away from the problem. I have 2 x's or x squared on top, 2 of them. I'm taking 1 away. That means I have 1 left on top. Okay, bring down the -9 because nothing's dividing the -9. I have 1 x on top. I'm taking 1 away. That means they cancel. They're gone. So this goes in parentheses, and we turn it into factor form by making it multiplication. So we multiply by our GCF in front. And that is GCF. Okay, let's jump over to 9. All right, we're going to skip 7. That's pretty much what we've been doing. So let's jump over to 9. All right, so now we have 3 terms. 1, 2, 3. So we got to compare 3 terms together, not just 2. So let's make a list. Again, I like to start with the smallest number and make a list there. So the smallest number I have is 7, and I want to make a list that divides 7. So it's only 1 and 7. Okay? So this is how I start doing it a little bit faster. Okay? Instead of making a list for all of them, I just look at these 2 numbers and ask myself, can 7 divide 14? And the answer is yes. Okay, so that means 7 is common with 14. And then I ask myself, can 7 divide 21? And the answer is yes. Okay, so again, I have found my GCF because 7 is the biggest number that can divide 7. Therefore, I'm going to check, can it divide the other ones? Which means my GCF is 7. Okay, if you want to make the list like I showed you before, you can. I'll do it for you just so you can make sure we're comfortable. This is 1, 7, 14. Those divide 14. This is 1, 3, 7, 21. Okay, and you notice the biggest number they have in common, the greatest common factor is 7. All right, now we look to the variables. Do they all have the same letter? All 3 of them have to have it, and they do. So we're going to pick the lowest power one. This is a power of 3, power of 2, power of 1. So x is my lowest power. There's my GCF, and we divide to every single term. Okay, 14 divided by 7, that gives me 2. We have 3 x's. I'm taking 1 away. That leaves me with 2 x's. We are done here. 7 divided by 7, that's positive 1. So I'll put positive 1. We have 2 x's. I'm taking 1 away. That leaves me with 1. Again, here you don't really have to put the positive 1 if you don't like. I'm just going to leave it. It's fine. Negative 21 divided by 7, that's negative 3. And here the x's cancel each other out. So this goes in parentheses, and we're going to turn it into multiplication by multiplying by our GCF in front. Okay, that's GCF factoring. Hopefully that's not too bad. It's also explained in the video on Monday. Okay. So real quick, I have a question on number 3. Okay. How did I get the t here by itself? Okay. So remember, we're going to go in this process. 7 and 10, do they have a common factor? And the answer is no. We cannot use 1. So that's why you don't have a number here. Okay. So now we look at the letters. Do they have a common letter? And the answer is yes. They have a common T. Okay? So that means when we have a common letter, that's part of our GCF. That's how I put T here. The only thing you have to be careful of is make sure you have the right power. How do I choose the power for T? You choose the smallest power. Okay? And the smallest power is 1. That's why it's T all by itself. Okay. All right. Let's move on to the next page. Okay. We're going to jump down to 13, 14, and 15. Okay, because this is asking you to use what is called the zero product rule to solve the following factored equations. So let me explain the zero product rule. Okay. Or the zero product property. It's said both ways. This is a way to solve polynomials. Okay, you're going to be asked to solve quadratics, which are a type of polynomial. This is what we have to do. The first step we want to do, we're going to do number 13 together, is make sure it's equal to 0. So if you look at number 13, it is equal to 0. We are good for number 13. The second step we want to do, and this is the hardest step of all, we want to turn our polynomial into a multiplication problem, kind of like what we've just been doing, okay? We want to turn it in what is called factored form, multiplication form, or factored form. And the way we do this is by factoring, okay? So let's check out what we have in number 13. Is my polynomial already in factored form? And the answer is yes. They already did step 2 for us. This is a factor because it's multiplying with another factor. So if you look at it, we have 2 factors here. This is in factored form because it's 2 guys multiplying with each other. 3x is one guy, x plus 5 is another guy. He's in parentheses, so we treat him as one guy. So it's one guy times another guy. This is already in factored form. We did not have to factor it, okay, like we were doing earlier in the other problems. So since it's in factored form, we move on to the next step, which is how we solve. You're going to take each factor and put it equal to 0. So my first factor, my first guy that's multiplying is 3x. We're going to put him equal to 0. The next guy that's multiplying is x plus 5. And we're going to put him equal to 0. And if you notice, you have 2 equations. You have the first equation, second equation. Okay? And all we're going to do now is solve it. So how do I solve for x here? And this is stuff we practiced earlier in the year. We're going to divide both sides by 3. We want to get x by itself. If you remember, we want to do the river, the line through, split them up. 3 cancels out. We're left with x equal to 0 divided by 3, which is 0. So that is one answer. Put the line in. We're going to subtract 5 here. X is equal to negative 5. That's my second answer. We have just solved using the zero product rule or the zero product property. Okay? Let's jump over to number 15. Let's go through these steps. Is it equal to 0? Yes. Is it in factored form? If not, we have to factor. Is it in factored form? Do we have a multiplication problem? Do we have factors that are multiplying? Okay? And the answer is yes. We got this factor is 1. And this factor is another. So once we are in factored form, so step 2 is done already. We're going to set each factor to 0. So 2 is going to equal to 0. And then x minus 1 is going to equal to 0. And we're going to solve. The only equations we solve here is the one that has a variable, or x. So if you look, this guy doesn't have an x, so we don't have to solve him. There's nothing to solve there. So we can ignore that guy. So we're really going to have one answer. We're going to solve for x here. That's going to be adding 1 to both sides. And x equals to 1. Okay? Alright guys, that's pretty much what you have to do this week. Okay? I did quite a bit of problems for you, so hopefully you can finish up the rest. Again, if you need extra help, you know my office hours are after school today. Just got to let me know you're coming in so I could turn in that Zoom. Okay? The answers to this are in the calendar, so if you need those, get those done. And other than that, I'm going to check you out. I'll give you the check-in code so you can check in and check out. And if you have any other questions, stay on and I can help you out, okay? Give me a second. Let me get the check-in code. All right, so the check-in code is DIRT, D-I-R-T. Go to the calendar to check in, and you are now dismissed. Get this work done.